Welcome to this video on adaptive boosting techniques. Today, we will break down key concepts, advantages, and implementation details of boosting. Let's get started. In this video, we will cover an introduction to boosting and explore its advantages and disadvantages. We will discuss the steps involved in adaptive boosting and how weights are updated during the process. Finally, we will show how adaptive boosting can be implemented in Python. Boosting is a sequential ensemble technique that builds models iteratively. Each base model focuses on correcting errors made by previous models. Misclassified instances get higher weights to guide the next model's training. Boosting has several advantages. It reduces bias in predictions and emphasizes weak areas of earlier models. However, it has drawbacks. High bias in a base model can lead to inefficiencies, and it is computationally intensive. Adaptive boosting involves several steps. First, assign equal weights to all data points. Then, fit the initial base model and calculate errors. Update instance weights based on performance and repeat until a stopping criterion is met. The slide demonstrates weight updates using mathematical formulas. It shows how boosting adjusts instance weights to focus on difficult examples. This code snippet demonstrates implementing adaptive boosting in Python using scikit-learn. It uses decision stumps as base models and applies the ADA boost algorithm. The code shows how to initialize, train, and predict using the ADA boost classifier. In summary, boosting is a powerful ensemble technique to improve model accuracy. Adaptive boosting dynamically assigns weights to tackle difficult instances. It is effective with simple base models like decision stumps. Practical implementation is straightforward with scikit-learn. Thanks for watching. If you enjoyed this video, please like, share, and subscribe for more content on data science and technology. See you next time.